Stanford University.
All right, here we are, Lecture 12, Stanford CS 193P, spring of 2020. Today's topic is core data, which is an object-oriented database. And we've been doing a lot of functional programming this quarter. Pretty much all the stuff we've been doing has been functional programming. We're going to switch over now to doing a little bit of object-oriented programming. Probably won't even notice the difference here, although core data is based on object-oriented programming, and Swift supports both object-oriented and functional programming equally. And we're essentially going to use this core data infrastructure to store and retrieve objects or classes in a database. Now, there's a very mature technology out there. It's been around for a long time to store large data sets. It's called SQL. But programming in SQL is very different than the kind of programming we're doing in Swift. SQL is a language, and it has its own syntax, and it's quite different. And it would be a bummer for us if all this learning we've done about how to program in Swift couldn't be applied to storing data. So we're going to get the best of both worlds here, because core data actually does its storage in SQL, but we're going to interact with our data entirely in an object-oriented way. We're not even going to need to know a single SQL statement to make this happen. Now, the heart of making this work in core data is this map, and it is a map between the objects and the vars on those objects and the tables and rows of a relational database. Now, if you don't know what relational databases are and all that, you really don't need to know, because you're going to be focusing on the objects and vars, not on the tables and rows in a relational database. And Xcode has a built-in editor for this map, which is really great. And this editor doesn't just let us specify the objects and vars, it lets us graphically create the relationships between objects, because that's really the important part, not just to have objects with vars on them, but you have objects that have relationships to other objects. We'll see that, some examples of that in a minute, and a big time we'll see that in the demo. So then what? You create this map. What can you do then? Well, Xcode behind the scenes is going to generate the classes, right? The code for the classes that represent those objects and vars that you created in the map. And we get to use extensions, just like we do with any other kind of data structure. We get to use extensions to add our own methods and our own computed vars to those classes. Of course, the storage vars are stored in the database. Then these objects that have been created for us and that we've extended serve as the source of data for the elements in our UI. So all of our SwiftUI that's doing everything, it's obviously putting data on screen. Right now we store them in view models where we have arrays and dictionaries and all that stuff. Well, now this data is going to be coming from this database, and we're just going to be accessing these objects to put it on screen, perfectly naturally, like we would normally do. So what are the features of core data? Of course, it has features for creating objects. You have to be able to create objects in the database, and it very naturally lets you change the values of the vars on these objects. You just change them. They're just vars, and you set them equal to something. Boom, you just change data in the database. And it even has beautiful infrastructure for establishing these relationships between objects. It's just a matter of setting a var, basically, to create a relationship between one object and another. And by relationships, I mean things like a flight has an origin airport. So flight objects and airport objects, they have a relationship. And there's, of course, a way to save these objects. And really importantly, you can fetch the objects from the database based on certain criteria. You want to say, I want all the flights that match this certain criteria, arrived at this certain time, or whatever that might be. It has a great, simple API for doing the fetching of the objects. Now, it has a whole lot of other database-y features on top of it, optimistic locking and all these things. We are not going to talk about this. This is an intro course, so we're just introducing the concept of core data here, but there is a lot of stuff in there to take this to pretty high levels. Now, let's talk about the integration of SwiftUI with this core data database. The objects that we create in the database are observable objects. They're essentially little mini view models. And there is also a very powerful property wrapper in SwiftUI called assignFetchRequest, which fetches these objects for us. So this fetch request is more than just a one-time fetch. It's kind of a standing query that's just constantly trying to match whatever the criteria you're talking about are and returning whatever's in the database. So as things get added to the database, if they match the criteria of that fetch request, then it's going to update your UI. That way our UI is always in sync with the database. Really, really fantastic. So how do you get core data into your app? How do you set it up? Well, the real way to set this up is when you create a new project, there's that button that you saw called Core Data, Use Core Data. You're going to click that, and it's going to do a little bit to set you up. Now, if you've already got an app and you've decided, oh, I want to add core data to it, I recommend going back and creating a new project and clicking this button and then moving all your source code over, because this button just does a really nice job of setting things up. So what does this button do? Well, it creates a blank map for you. This map that I told you has a built-in editor. You get a blank one of those so you can start adding your objects and your vars. It adds a little bit of code to your app delegate, which I'll show you in the demo. You haven't seen it yet. There's really nothing much of interest in there to us, but it does add this little bit of code that creates the database store, the actual SQL database that the stuff is going to be stored in. So you don't ever need to go look at that code even. It just all happens automatically. I just want to let you know that it does do something in there. Now it does add a couple of lines of code to your scene delegate, right where you create the content view there. One of the lines of code goes and reaches into that store, the SQL store code that was in the app delegate, and it grabs something called an NS managed object context. And this context is crucial to using core data. It is the window through which we see that all the objects in our database. And you're going to see that we need the context whenever we create objects, we do fetches, any of that stuff. So these two lines of scene delegate code are to go grab that context out of the store. And then the second one, interestingly, is to pass that context into your SwiftUI views via the environment. And we already saw environment, for example, with the edit mode. And this is using environment again so that all your SwiftUI views will have this context so they can see the database and get objects out of it and all that. So that's added to your scene delegate. And that's pretty much all the setup you need, because now you can create objects, fetch them, whatever. You have the window into the database you need. You've created your map, do whatever the objects and vars you want, and you're on your way. So let's take a look at that map. I'm gonna, since the demo is gonna create a detailed map with airports and airlines and flights in our Enroute, there's no reason to go over it here, but just to give you an image in your mind what it looks like. You know, here's an example. On the left, we have, it looks like that is a flight, and it's got some attributes like when it arrived or it's going to arrive and its ident, and even some relationships to other objects like the destination airport, the origin airport, the airline. And then on the right, you can see this graphical map of the relationships between airports, flights, and airlines. For example, if you see flight, it's got this relationship to airport, which is the origin, and another relationship, the destination. And notice that the airport has relationships back along the same line, which is the flights from this airport and the flights to this airport. Now, that origin and destination relationships in flight, those are just airport objects. That's the type of those vars. All those little black words you see there, code name, short name, aircraft, those are all just going to be vars inside my flight object, my airline object, my airport object. And destination and origin are just vars, and their type is going to be airport. Now, the flights from and the flights to, they're a little interesting because there's multiple flights to and from an airport. So those are actually going to be sets of flights. That's the type of that var. It's a set, kind of an old Objective-C style set. And we'll talk about that in the demo, but that's what's going on there. So all these things that we see on the screen are just turning into objects, airline, flight, and airport objects with vars, aircraft, arrival, departure, file. Those are all just vars on each of these things. That's what this map is doing. And that's pretty much all there is to it with the map. So once you have this map, and now you have the window that was passed into your environment that we talked about from your scene delegate, what can you do? Well, you can get that window, that managed object context via your environment. It's /managed object context. So now you have this context var, and you can use it to do things like create an object. You just do that by saying flight with the argument context, so that it knows the window into the database, and it'll create you a flight. Now you have a flight, this green flight var here, and you can just start setting the vars on it, like the aircraft. Set it to be B737, Boeing 737 aircraft. And here's another thing. I'm creating an airport called KSJC, and I'm just setting its ICAO, which is its unique identifier for an airport, to KSJC. And I can even do pretty powerful var setting, like if I set the flights.origin to KSJC, because KSJC is an airport and the origin is a var that is of type airport, then that sets that relationship. And that will also affect the opposite relationship of KSJC's flights from will automatically get flight added to it. So you don't even have to worry about the balancing of the two sides. One's a set of flights and one is the origin. It automatically keeps both sides. And if I had added it to the set of flights, then it would set it as the origin on the other side. So it's pretty cool system in that way. So it's just objects and vars. See, just that looks all like objects and vars to us here. We don't know anything else about SQL or tables and rows, just objects and vars. Saving it, really easy, context.save. This throws, however. Now, why would trying to save it throw? Your disk could be full, for one thing. It's extremely unlikely, but your iOS device doesn't have unlimited storage. And there could be possibly other errors, but generally this is not going to fail, but it can throw. So that's why we have to put the try on there when we save. Now, what about fetching objects, getting them out of the database? Well, we do that with this very important object in core data called an NS fetch request. All right, it has a don't care there, which is the kind of thing that you want to fetch. And you create one just by specifying the name of the thing in your map that is that thing you're trying to fetch. So flight in this case is what I called in my map the objects that are flight. So this is going to create a fetch request that goes and fetches flights. That's what this request is. Now, how does it know which flights to go and get? Well, this request has a var in it called predicate, and you assign it a NS predicate. You're definitely going to want to look in the documentation of NS predicate and see all the incredible wide range of things it can do to specify which flights you want. So for example, I've created a predicate here. Predicate kind of has a little bit of a printf kind of a feel to it. This has been around a very long time, well before Swift ever existed. So it's a little printf-y. And so my predicate here is that I want arrival is before something and the origin equals something, and then I provide the somethings. The first something is the current date and time, and the second one is KSJC. So this predicate means show me all the things that have arrived before now, so they're already arrived, and their origin was San Jose. They came from San Jose. So that's the predicate I'm doing here. So it's a little bit, texty kind of oriented predicates there, but you definitely have to go look in the documentation for NS predicate to understand all the things that it can do. So that's specifying which of the flights I want in the database. Now there's one other piece of request that you need here, which is something called the sort descriptors. And that's because when we make this request into the database, it's going to come back as an array. And that array has to be sorted. And we specify these sort descriptors so that the sorting can happen on the database side. SQL database is super good at sorting things. And so we're going to let it do the sorting if possible. And we do that with this sort descriptors var. It's just an array of these NS sort descriptors. The NS sort descriptors simply say what var, ident in this case, that's the flight identifier, that you want to sort by, and whether you want it ascending or descending, right? Alphabetical order A to Z or Z to A. How do we then ask our context, our database, go fetch these things for us? Well, we do that with the fetch function. So we say context.fetch this request, and it's going to go out to the database and go find all the flights that match this arrival and origin predicate that we have and return them to us. Now this fetch also can throw. Just like save can throw, so can fetch. And so we'd need to try it. And a lot of times we'll do a line of code like this, let flight equals try question mark, and then the context fetch. If we do this, then that flights var is either going to be nil if the fetch failed, empty array if it did not fail but no flights matched our predicate. Otherwise, it's just an array of flight objects, the ones that matched. So again, very object-oriented. I'm just getting these flight objects that match my predicate. I just threw all this on one slide just so you get a feel for all of the code, and so you have kind of a quick reference guide to it. But we are, of course, going to do a big demo that shows all this stuff happening. Now, what about the integration with all this stuff and SwiftUI? Well, there's two major points of integration we talked about. One is this observed object. When you have a flight as a var in one of your SwiftUI views, it's going to be an outside observed object. You can then use it to do like text flight ident here and just show the ident on flight, whatever you want to do. It's just an object. The observed objects, by the way, as far as I can tell, do not seem to fire automatically when things change in the database. So if you want them to change, you need to explicitly call object will change. But these do make these flights and airports and airlines feel like little mini view models. And that's really what they are. They're little view models on a little flight. But a lot of times what we want to show in our UI is more than just one flight or one airline. We want to show all the flights, for example, that match a certain fetch request or predicate. And so there's another really important feature in SwiftUI called the fetch request property wrapper. Now this property wrapper, you create it with the arguments, either the same arguments that go to a fetch request, which is the entity, remember that entity name thing was flight, and the sort descriptors and the predicate, so you can create a fetch request that way, or you can actually create a fetch request just by giving it a fetch request you created. Either way, you're specifying what things you want to fetch. And this is a property wrapper, right? So it's wrapping some var. And the type of the var that it wraps is called a fetched results. Also has a don't care, and that don't care, of course, is what kind of thing it's supposed to fetch. So that better match whatever your fetch request says that it's trying to fetch. Now this fetched results var, it's a collection, so you can pass it to for each, as you'll see in a second. But so it's not an array. But if you wanted to turn this thing into an array, really easy, you could pass it to an array as array's initializer, because an array knows how to take any collection and turn it into an array. You could also send it messages like sorted. Sorted can be sent to any collection, and it returns an array. And that collection is full of those kind of objects that you're fetching, flight objects or airport objects. Now, what's cool about this var that you're creating here, flights or airports, is that it's continuously trying to fetch that fetch request. All right, this is not a one-time fetch where it's going to fetch that and give you the results. It's continuously doing this fetch. It's like a standing query. And so every time a new airport or a new flight is added there, or even if an existing airport or flight changes one of its vars so that now it matches your predicate, it's going to update. And when it updates, your SwiftUI is going to get invalidated and redrawn. And so your UI is always going to be showing what's in the database. You don't ever have to tell it to go fetch. And this is all part of the declarative nature of SwiftUI. You don't say to do things in SwiftUI, you just declare that things are a certain way, and they always are that way. And of course, with core data, we always want them to look like whatever is in the database. So we tend to use @ fetch requests, sometimes even when we're just fetching one object, right? We might be having the predicate just be like ident equals something for a flight. That's ever only going to match one flight. But the great thing is if that flight changes, this is going to be updated. That's why the fact that the observed objects up there that we were talking about don't seem to kind of do their object will change when something changes, that really is not a big problem, because we would just maybe have a fetch request that fetches that one thing, and that will change. Because fetch request is always tracking what's happening in the database. It's really a fantastic property wrapper. This API that you're seeing right here is a really elegant, simple one thing to make it so that your UI is always matching up against core data. So it's really, really cool. By the way, I show the fetch request up there. I'm creating it when I declare the vars with the fetch request I want. But of course, you could just declare, and I'll show you this in the demo, and then use your init and set the underbar flights, right? Underbar flights is the actual struct, the fetch request struct, to be something you create then. So if you're passing the predicate in, for example, that you want to use, you can pass it into your init, and then your init can just initialize that fetch request thing. Just like we've initialized bindings this way, state with its wrapped value, you can do the same thing here. And we'll see that in the demo. And speaking of which, let's dive right into the demo and show you what it looks like to do all this stuff. Our goal in this demo is to convert our Enroute to use our core data database and store all the information that comes down from FlightAware into a database, and then build our whole UI by just looking in the database. Right now, we actually fetch this stuff, and as it comes back from FlightAware, we're showing it in our UI directly. Here, we're going to fetch it all from FlightAware, put it in a database, and then have our UI totally just looking at the database. And this is a common kind of paradigm for developing an application that fetches data instead of trying to keep up track with it and get it all the latest information all the time. You just throw it in a database. And so you're always looking at the database. It makes your code a lot simpler on the UI side. That's exactly what we're going to do. Now, if you want to use core data in your app, the best way to do it is when you say new project over here, click this button, use core data. If you click this button, use core data, you're going to get the small amount of very important code that hooks you up to a database. This additional button, by the way, use CloudKit. That's pretty cool. That will make it so that everything you put in your database gets mirrored up to iCloud. And that way the user will see it in all their devices in core data. Pretty amazing. We're not going to do that part of it. This demo is already long enough. So we'll just focus on the core data part, but it's really not that complicated. If you're interested in that, you can certainly look up how to do that. Now, if you've already started your app like we have with Enroute, and you want to add core data functionality to it, I actually recommend doing what I did, which went right back and created a new project anyway, and then just copied and pasted all my code, dragged my files back into the new project, because this little switch, it does a really good job of just setting things up. And so let's look at that setup. Let's see what it is this little switch did. And really it added two important pieces of code. One is right here in this thing called app delegate, which we haven't even looked at app delegate yet, but we're going to look at it right now. And here you can see it's added this thing called core data stack with this persistent container right here. That's the thing that holds your core data database. And so we are going to use this to access the database. And in our scene delegate, where we create our little flight Enroute view, notice it's added a couple of lines of code here. This context, which looks in that persistent container we were just talking about, and gets something called a context. And this context is then passed via the environment to all of our views. And we want to be very sure that when we put up a new environment of views, like when we use a sheet or a popover or something like that, that we pass this along to it. Now remember, an environment, when you give it to a view, all the views that are in its body, actually in its body, get the same environment, so you don't have to pass them there. But if you do a sheet or a popover, now you're kind of going off to a new base body, and so you do need to pass. And you're going to see that because, of course, we do a sheet. In this app, we have that filter flights. So this context is our window onto the database. Where is the database itself, or what is the database? And the database is something we design using this little file right down here, which is also provided by that use core data. Here it is. This is all of the objects that we're going to create in our database. Now remember, this is an object-oriented programming layer on top of, in this case, a SQL database, right, or a normal relational database. And so it's doing all the mapping for us. We have no idea that that's a SQL database, and we don't want to know. We're just going to create our objects. And that's what this tool right here, this tool that's editing this XE data model D file, is letting us do. Define what objects we want in the database, what vars are on those objects. So let's dive right in and create our objects. This is Enroute. What objects do we have? Well, we have the flights. That's the main object, all these flights that we're showing. But we also have some kind of helper objects like the airline and airport objects. So let's create flight, airline, and airport objects here. This entities is the list of objects that we want, and we add them down here where it says add entity. So boom, there it is. Let's call our first entity airport, and let's add another entity. Call this one airline, and our third entity, which is a flight. So we've created the objects right here, but they have no vars. This on the right over here is showing the vars, especially this part in the top here, attributes, and none of our objects have any vars yet, of course. Let's start with the simplest one, airline. It only has 3 vars. It has a code, and this code is of type string. So this is how we add a var. We just press the plus, give it the var's name, and then its type. It also has a name. The name is also a string, and that's the full name of the airline, like United Airlines Incorporated, something like that. But it also has a short name in the FlightAware information that comes back, and that's like United, just short and sweet. Well, not quite a nickname, but a shortened name of it. And that's it. That's all that comes back from FlightAware from airline that we're interested right here. What about airport? So airport has a very important thing called the ICAO. That is a string. That's like KSFO or KDFW, KSJC for San Jose. That's its unique code. You notice they all start with K. That's airports in the United States start with K. So that is a very important one for us to have, obviously. But you also get kind of cool things like we get the latitude and longitude. Those are doubles. Those come across from FlightAware as numbers, and so we're going to store them here in our database as doubles. Got some other stuff like the location of the airport. So for San Jose, that's San Jose, California is the location of it. And we also have the time zone that it's in. When we fly around up there in the skies, all the pilots, everything is going on in GMT, right? Greenwich Mean Time. So it's nice to know the time zone of the actual airport we're going to so we can convert to local time. And then all the airports have a name. Like I think San Francisco International Airport is its full name of SFO. So that's airports. What about the flights? Okay, flights have something called in FlightAware an ident. This is like UA 475, United Airlines Flight 475. That's its unique identifier. We definitely want to be able to uniquely identify our flights. Our flights also have aircraft. So this is like a string that 737 or something like that. Of course, we have the arrival time and departure times. Those are dates. We're going to go date here, arrival and departure. And it turns out that flights also have another date, which is their filed departure, because some flights are still on the ground. They haven't left yet, either delay or they're not scheduled to leave yet, but they've filed, the pilot has filed for a certain time that they want to depart. So that's it. These are our objects and their vars. But there's one more piece to our object-oriented puzzle here, which is the relationships between objects. For example, a flight has an origin and destination airport. So it has a relationship there. That a flight also has an airline. So we can add these relationships in this section here, relationship, but we usually don't do it that way. Instead, we go over here down to this editor style in the corner, and we switch from this kind of table-oriented one we're at to this graphical version. And this is giving us the same information as we just had, but in a little graphical version. And these individual vars, if we click on them, we can see the types and all that by going over here and bringing up this third pane inspector, which we really have not looked at all quarter long because SwiftUI doesn't really use it that much, but really valuable here. It's the fourth tab over in this inspector and showing us location is the var, and here's its type. Notice it says optional right here. This does not mean optional like Swift optionals. This means it's optional in the database. So this, unfortunately, this has the exact same name, but it really has nothing to do with that. All of these vars in Swift will be optionals. Okay, and that's really a design decision there that's made because your database might be corrupted and you might think that all of these things have values, but they don't. The object was started to be created and it failed, and so now these vars aren't set. So that's why these are optional. And I'm going to show you a little bit of a design strategy or whatever in my code to kind of identify the ones that really should never be optional and cover them a little bit with some syntactic sugar, or really I'm just going to use a computed var to make them not be optional. You'll see how we do that. But by default, all of these are optional, and that has nothing to do with this switch right here. So we can set other things, default value and things like that. But mostly what we're doing here in this graphical arrangement is to create connections between these objects. For example, let's talk about our flight. It wants its destination airport and its origin airport. So how do we do that? Well, we do that with the control key. So I'm holding down control. You can see the plus appears. I'm going to drag from my flight over to my airport here and let go. And it creates a little relationship here, a little line. Now, this is just going to be a var on each side. On the flight side, it's currently calling this var new relationship. I'm just double clicking on it right there. But I actually want this to be my destination airport. So I'm calling this var destination. Now, what type is this var going to be in my code when Xcode creates all the code that makes this object stuff work? This is just going to be a var that is a type airport, because this airport is an object. We're doing object-oriented programming here. Each of these is a kind of new object that Xcode is going to create the code for us. It's really kind of cool. Now, what about on this side, airport? Well, this relationship here is really like the flights to this airport. And this is flights plural, because if I have 20 flights all going to the same airport, well, then this is kind of got to be multiple flights or something. How does that work? Because this can't be a flight. This has got to be like a bunch of flights. And indeed, the way we do that is we can inspect this particular relationship and say that instead of a 2-1 relationship, where there's one flight per airport here, it is a too many relationship. And you can see that the arrow became double arrow. Now this is no longer just one flight, it is multiple flights, which makes sense. An airport has multiple flights that are heading to it. And what is going to be the type of this var? This var flights to. Its type is going to be a set of flights. Unfortunately, it's not a Swift set of flights. It's the old Objective-C set of flights. So you're going to see us having to do another little bit of cleaning up syntactic sugar or computed var to make this into be what we want, which we really want to be a Swift set of flights, not an Objective-C set of flights. And this is one of the few places where Objective-C leaks through in core data, unfortunately, but easily fixed. Now, I'm going to do another control drag from flight up here for the origin airport. So that new relationship down here is origin. And up here, this is the relationship on this side is flights from. And this flights from is also a too many relationship. So both of these are too many relationships. And airline, same thing, the flight, of course, every flight is operated by an airline. So we'll have the relationship here called airline on this side. And similar here, this is flights. These are all of the flights being operated by this airline. So that is a too many relationship. Now, all of this work we're doing here to connect these up and create these little relationship vars, we can see it back in the normal editor style right here. So here's airline. It has flights. Airport has flights from and to. Flight has destination, origin, and the airline. So that's it. That is how we build our object model here. All the code that's required to make these objects exist and have all these vars exist is totally done for us by Xcode. We just hit build here. It goes through and creates all the code that's necessary to make that work. The only code we're going to add is in extensions. So we're going to add some code in extensions here. This is object-oriented programming. Of course, we want our objects to do more than just have these vars. We want it to have some behavior as well. We'll be adding that behavior using extensions. Let's go back now. Now that we have our whole object model here, we have all the objects we want to create. Let's go use them in our UI. So here's our UI code that we built from last time. It's still based on this flight fetcher mechanism. And we're going to completely replace the flight fetcher. I'm going to eventually comment flight fetcher out completely. And instead, we're going to use an object-oriented approach to building our UI. By the way, before we get started, take a look at the top of this file. You see import core data. You want to make sure you're importing core data in any files that you're going to be doing this core data stuff in. Otherwise, symbols like NS managed object context are not going to be defined. And I'm going to start with this very important struct right here, flight search, which currently is looking up airports by their codes and airlines by their codes. And I'm going to switch this to be object-oriented. My destination is not going to be a string like KPAO. It's going to be an airport. And same thing here, my origin is going to be an optional airport. And my airline is going to be an airline. So this is going to totally transform all of our code to be object-oriented. By the way, sometimes when you build put your object model, the rest of your code won't get the message about it. Like we still have undeclared airport. Again, it's Xcode's going to be building that for us behind the scenes. Usually we'll just try a build here. Sometimes that'll fix it. No, that didn't quite get it. Another one to do is go back to your model over here and just do a build. Sometimes that'll get it going. Let's see if that fixed it over here. And it looks like that it did. So let's see what kind of errors we got. So we still have a bunch of errors, obviously. Our whole code is based on this thing being strings, and these are no longer strings. So let's just work our way through the problems that we introduced by changing this to be object-oriented and fix them one by one. And along the way, we're going to learn a lot about how to create these objects in the database, how to go look them up and find them in the database. That's all going to be part and parcel of using core data to make this stuff object-oriented. So let's start with the very first one. It says here, cannot convert value of type string to expected type argument airport. Okay, we already see one case here where it's using a string for an airport instead of the airport object. So let's click on this. Takes us to our scene delegate. And sure enough, right here, we're trying to create a flight search with a string, which again, destination and flight search used to be a string. We just changed it to airport. So let's create a little local variable to be our airport here. And I'm going to say let airport equal something. And this airport has to be some sort of airport object. Now, it is possible to create an object directly using this thing called the context, right? The context we talked about is this window into the database that we get from that little use core data button right here. And this context is super important. Everything we do is going through that window of it to the database. That's how we do everything in the database. But we're not going to do that here because it might well be that this airport that I'm trying to create here, which I'm essentially trying to create the airport KSFO, right? This airport might already be in the database. So I kind of leave a little function here, which I'm going to call with ICAO, which takes this string and looks it up in the database. And if it finds an airport object, it gives it to me. And if it doesn't, it makes one. And not only makes one, but goes and fetches it from FlightAware too. So that's what this little function is going to do. Now, how do we add a function to our airport object that Xcode created for us? We're going to do it with an extension. And we're just going to extend this class, this object-oriented class airport, to have this static function, which lets us look an airport up by name. So let's go do that. I actually created that file here, airport, and it's a blank file for now, and I'm going to say extension of airport. And here I'm going to do this static func with ICAO, and it's going to take that little special code that I was telling you about, and it's going to return an airport. And this is going to just look up that ICAO in core data, and if it finds it, return it. If not, then we're going to create one and fetch from FlightAware. So that's what this function is going to do. So let's start with this lookup. Well, still complaining about that. We won't worry about that for now. We want to look up this code in core data. So how do we look things up in core data to see if there's something there? We do this with a very important object called a fetch request, NS fetch request, in fact. So I'm going to let request equal an NS fetch request. Now, NS fetch request is generic. It has a don't care, which is the kind of object you're trying to fetch. Then you specify the entity name as a string, and this string is just whatever you put here as the name of your entity, so airline, airport, or flight. So this is how you create a fetch request. Now, a fetch request is essentially a guide that we're going to use to have the database know which airport we want or which airports. We might be looking for multiple airports. We might be looking for airports by time zone, so we get multiple airports here. And this request is going to let us specify which ones we want. So the request has two really important parts to it. One is called its predicate. And its predicate is the which ones do you want? And you create that with an object called an NS predicate. And it kind of has a printf sort of feel to it, where you give it a format for what you want to search and then any arguments that fit in there. So it's again pretty Swift, so it doesn't feel super Swifty because it's printf-y, but you'll get used to it really easily. And for example, in our case, we want the ICAO to equal something. And what is that something? The ICAO that is passed to us up here, right? This argument ICAO, I want my predicate to be go look up this var in the database with this value. And you can do things like and another one of them, or something else equals something else. And there's even more powerful things where you can do pattern matching and begins with and all kinds of things. This predicate object, obviously, if you're going to do this core data, you're going to need to go look that up in the documentation and understand all the powerful things you can do to go figure out which objects you want from the database. The other thing that we want to know here is the sort descriptors. Now, the sort descriptors are an array of these things called NS sort descriptor. And a sort descriptor has two things. One is the name of the var you want to sort by. And actually, if I'm looking for airports, I'm going to sort them by location, by the city that they're in. And then the second thing is whether you want them ascending in order or descending, and I do want this ascending. Now, why is this important to have this sort descriptors here? That's because when we look up objects in the database, they're going to come back as an array, not as a set, but as an array. And it's an array because they're ordered, they're put in this order. And why do we do that? Why don't we just get a set instead of an array? Well, because sorting like this can happen on the database side very, very efficiently. And notice it's an array of sort descriptors. So if you had people in here and you had first name and last name, you could have a sort descriptor to sort by last name and then another sort descriptor to subsort by first name. That's why this is an array of sort descriptors. So that's all we need to do to create this fetch request. This is describing what we want out of the database. So how do we get it out of the database? We use this little function, let airports equal context.fetch request. Now, this context is one of these things from back over here, right? This context that we're passing in our environment, this context here. That is the window on the database. If we want to fetch something out of the database, we need that context. So we're going to have to pass that along to with ICAO. I'm going to say here context, and then in with ICAO, I'm going to have another argument here, context. And this context is of type NS managed object context. This fetch method, though, has one other interesting thing is that you have to try it because it could fail. No connection to the database or something like that. So it's possible it can fail. Now, if you remember, if we do try, we could do and catch and try it in there and catch the error and see what the error is and do things. Here, if I try to do this fetch and it fails, I'm just going to let this whole thing return nil. That's what try ? Hopefully you remember that from your reading about error handling. That's what it does. So this would be nil. Now, if this doesn't fail, but there is no airport matching this, then this is not going to return nil or fail. It's going to return empty array. So calling fetch and getting back an empty array means I couldn't find it. That's different from nil, which means I had an error trying to fetch this. Now, if it does find it, then this is going to return an array with all the airport objects in it that match. And we said this is a fetch request for airports, so this is going to return an array of airports. Hopefully, this will never return more than one airport because ICAO, it's like KSFO, there should only be one in the entire database. That's why we're doing this thing of looking it up first before we go create it. So what I'm going to do here is kind of ignore the errors. If this comes back nil, then I'm going to optional default it to the empty array. If I were shipping this as a real app, probably would catch this error here and trying to figure out what am I going to do because I fetched this airport and it failed. Probably if this fetch fails though, all your core data stuff is going to start failing. So, that would be a top level failure that you'd have to handle anyway. So now this is going to be an array. It's either going to be an empty array if there was a failure or if we couldn't find this, or it's going to be an array hopefully of just one thing, which is the airport object that we've put in there in the past for this thing. So let's check those cases. First, I'm going to say, if I can let airport equal this airport's dot first element of the airport, then I found one. And so I'm just going to return it. Easy enough. This is the first part of this lookup. CAO, I did this. And so now if it found, return it. Otherwise, we're in this case down here where we couldn't find it. And now we need to create one of these things and then fetch it from FlightAware. How do we do this? I'm going to create the airport first with just its ICAO. I already have that information. I don't have to fetch that from FlightAware. It was passed into me here. So let's create the airport. I'm going to say let airport equal airport. And of course, we have to pass that context because we have to really tell the system which database to create this airport in. But this creates an airport. And then I'm going to set the airport's ICAO var, right? Our airport here has an ICAO var. How do I set this var? Amazingly, I just say .ICAO equals ICAO. And again, Xcode has built all the code behind this that makes this an object that has this var. Now, it doesn't seem to still be recognizing that. We can get it to do that. Okay, so now we got that to compile here. So now we've created an airport, and it doesn't have any of these other vars that we want in here, like latitude, longitude, all that. That information all comes from FlightAware. So there's no way for me to say airport.longitude equals some right here. So it's just going to be nil. Those values are going to be nil in the database. Again, that's part of why these vars are all optionals. Even the ICAO is an optional, even though we're always going to be setting it here. It's an optional because it might not be set in the database. So how do we fetch stuff from FlightAware? In this FlightAware code that I have over here, one of the things we have is an airport info right here. And the airport info gets to this struct called an airport info request. And it has function fetch. You give it the ICAO you want, and it will call you back later once the information comes back from FlightAware and give you an airport info object. So an airport info object looks like this. Got the ICAO, latitude, longitude, all these things that we want to put in the database. I'm going to call a function here, self.update from airport info in the context. And this little static function that we're going to do, static func update from airport info. I'll just call it info here. This is an airport info object from FlightAware. And we need the context, of course, because we're going to be doing something in the database. Anytime we're doing something in the database, we need the context to know which database. So in this update right here, by the way, once we do this, I'm going to return this airport right away. Now, when I first return this airport, it's only going to have the ICAO in it. It's not going to have all this. This is asynchronous. It's happening later. So when someone says, give me the airport with an ICAO, and I've never seen it before, I'm going to give them back a mostly empty one that just has ICAO. So if I'm going to have to make my airport be pretty tolerant. All my code is going to be tolerant of all those other fields being nil, which is fine. They're just going to have to check to see if they're nil. But this one, we can pretty much always count on not being nil, and we're going to talk about how we're going to deal with that in a second. So update, how do we do this update right here? So this is happening sometime later. It comes back. So I'm going to say if I can let the ICAO equal this info's ICAO. So this is the info coming back from FlightAware. I'm going to see if I can get the ICAO out of there, which I should be able to do. Then I'm going to look this airport up by calling my own with ICAO function in this context. Because this is happening sometime later, right? This closure happened sometime later. So now I'm going to go back and call this again to get this airport that I created earlier, actually, the one that just has the ICAO in it. I'm going to go back and get it because this is all happening later. Then I'm just going to set all the fields, okay? The latitude equals the info.latitude and the longitude. Longitude. So I'm going to type all these fields in. Next step I want to take here is to save this information into the database. Now, that can be done by asking the context to do a save. But you can see here that the context save throws, see where it says throws right there? Anytime you see throws, that means that this is a function you have to try. And I'm happy to try this, and if it fails, just do nothing. Now, this is not all the vars on my airport, though. If I go back and look at my airport, I've got all these vars, but oh, what about these? Flight from and flights to. Well, flight from and flights to can be set from either side. You can either set it by having a flight set its destination to an airport, and that's going to cause the flights to set to get an airport added to it automatically. You don't have to do anything. And vice versa, if you add something that's flights to on this side, it's going to cause that flight to point back the other way. So that's pretty cool. That's automatically managed for us. Now, what about one other thing we want to do here? So we've created this thing, we saved it. Remember that these airports are observable objects. They're little mini view models. So I'm doing a wholesale update right here. I'm going to actually tell this airport to fire off its object will change.send. That's going to cause any views that are looking at this airport right now to redraw themselves and hopefully pick up this new information if they depend on any of it. I'm also going to do another thing too. I'm going to have the airport flights to, I'm going to have each of them for each do their object will change.send. I'm going to do the same thing for my flights from. Now, this doesn't work because of what I was saying before, that these flights to and flights from are NS sets. You see that? The value type NS set. So you can't tell an NS set optional here to do this. And even if I make it non-optional, that's not going to fix the problem either, because it's not only an NS set, it's an NS set of any. So it doesn't even know that these flights to are actually flights, flight objects. So this solution here requires a little bit of what I call like syntactic sugar, not added by the compiler, but something we're going to add. I'm going to make flights to and flights from be little computed var. Flights to, I'm going to have be a set of flight, and I'm going to have a get and a set, and the same thing with flights from. Now, how am I going to do this flights from and to as computed vars? Because I already have flights to and flights from vars from over here. And my airport already has these vars. These are vars. So I'm going to rename these vars over here to put a little undervar after them. And this is just something kind of I like to do when I have things that are a set right here, and I'm going to do it for other things later, where the thing in the database is almost exactly what I want, but not quite. So this is a set of these any from kind of Objective-C version of this thing. And I'm going to have my flights to get by returning the flights to underbar as a set of flight. And oh, by the way, if that is not set, then I'm going to return an empty set of flight. So here I've kind of done two things at once. I've converted flights to be not be an NS set and instead be a set of flight. And I've also checked to see if flights 2 might be nil, and if it is, return an empty set instead. So setting it is easy as well. Flights 2 underbar equals our new value as an NS set. So the Objective-C versions of the set and the Swift version of sets can be ased. This is typecasting, you hopefully remember from reading again. They can be as directly as each other, which is really a cool feature, very big compatibility feature to have that work. So my flight from is pretty much exactly the same thing, but we're doing flights from here and flights from. Okay, so everybody hope you understand. I'm just trying to make my code here look really clean and sweet by making it be set of flight instead of being this NS set of any and possibly nil as well. Okay, so that's all I think I need to do here to create an airport or find one that's existing. So if I go back over to my scene delegate here, oh, look at that. All that code just compiles perfectly fine here. Now, this thing that I did with airport here with flights 2, again, not only switching from set to NS set, but also checking to see if it's nil, so that this flights 2 at worst is ever an empty set, not nil. I like to do that with all my other vars too that can't really be nil. For example, let's go look in airport here and see which of these can never or should never be nil. Well, actually, any of these can be nil, and they're all going to be nil while I'm doing my fetch, except for not this one. ICAO never really should be nil. So I'm going to put an underbar after it. And then in my extension over here, and I actually have this commented out here so that we can speed this along, I'm going to create a similar sort of var. This one's not doing the set NS set thing, but it's just making this thing be not optional anymore. So it's taking the underbar version and make it not optional. Now I have a to-do here, you see, that when my app ships, maybe I want to do something else here when this thing is nil, because it's really an error condition. This should never happen, because when I create an airport, the very first thing I do on the next line is set this ICAO. This can really never happen that this is nil. If this did, it's some error condition going on. So I could possibly try and handle this error condition better than just crashing, because we know that exclamation point is just going to crash. But certainly for this demo and while I'm in development, maybe I want this to crash while I'm in development. I want to see the cases under which I can get this kind of corrupted database to happen. If ever, may never happen that this can happen. Okay, I've also added some other things down here, a friendly name for the airport just by looking at its name and location, creating that. I've also made airports identifiable and comparable. It's usually a nice thing to do with your objects from core data, so you can put them in dictionaries and sets and things like that. So we've done a lot of great stuff here with airport, and we've learned a lot about core data just from doing airport. We know how to fetch them, we know how to create new ones, we know how to do this little thing where we make our sets look a little nicer. We know how to kind of cover our can be optional ones. And in fact, let's do this little can be optional cover for our other things as well. We have airline over here. So I've done the same thing here. Now for airline, I want code, name, short name, and then of course we're going to do the flights set magic here. So code, name, short name, flights, that's pretty much all the things down here in airline. So we can make that an underbar, name, an underbar, and short name, an underbar, and flights also here is underbar. And how about flight? So I did the same thing for flight, which we haven't even looked at flight. All right, so flight, I made the arrival, the destination, origin, airport, the airline, and the ident. All of these things can't be nil. And then I added this nice little number thing. Let's go over here to our data model for flight, and aircraft is fine. Arrival, make that arrival time can't be nil. Departure time can be nil. File can be nil. Ident cannot be nil. And then all these relationships, we're going to just protect them against being nil. Okay, so that's all we've done there. This just makes our code nicer. We don't have to be constantly checking to see if the ident is not nil, because a flight's ident really can never not be nil. If a flight doesn't have an ident, it doesn't even exist really. And same thing, arrival time. Flights have to have at least an estimated arrival time. Now, one thing to be careful of when you go through and do this kind of getting rid of the optionalness of things is that your fetches, like this fetch right here, it still has to use the underbar version, right? It can't not use the underbar version for that. Anything you make not have the underbar, this request right here, this predicate, it's doing fetching on fields in the database, not bars in your code down here. It's actually fetching in the database. So this has to be a field in the database. Same thing with sort descriptors. Now the location, if we look back here at airport, this location, we didn't underbar that. So we don't want the underbar there. It means we don't want the underbar here either. Okay, so we fixed all of that problem that we originally had here in Scene Delegate, where we were trying to create a flight search with KSFO. Instead, we just made ourselves an airport object and passed that in so that our flight search was now taking a destination that was an airport. Okay, let's continue to chase after our bugs over here that were introduced by making this all be object-oriented. This one says binary operator equals between string and airport. Of course, another one of these. Where is that? That's in Flight Fetcher. So I'm clicking on that. So this is part of the private implementation of Flight Fetcher. Yeah, of course. Flight Fetcher is all non-object oriented. It's based on strings and fetching strings. So Flight Fetcher itself is just going to be completely useless. So let's go back to our flight Enroute and go look for Flight Fetcher. Here's where we use it in our flight list. Fetch flights, obviously, for our flight list. This whole thing is useless. I'm just going to delete all this Flight Fetcher code because we can't use any of it anymore. So how do we do the equivalent, though, in core data? We want to go fetch all those flights and for each through them. Well, it's a pretty cool integration here between core data and SwiftUI. I'm actually going to create a var for those flights right here. And I'm going to do that var using a property wrapper called @fetchRequest. And it takes some arguments, which we'll talk about in a second. And this return value of something that is using this property wrapper is called a fetched results. And it has a don't care, which is the kind of thing it's fetching, which is flight. So this flight, remember, that's our flight that we're creating here from our database. And we're going to issue some sort of fetch request to get some flights. And this var is going to be this fetch results. Now, what is a fetched results of flight? It's not quite an array of flights, although it is a collection. So it'll work to put it right here in for each. It works just fine because this is essentially a collection. And that's what for each is looking for, a collection of identifiable objects, basically. This is essentially the result of this fetch request as a bunch of flights, which is exactly what we want. Now, how do we specify this fetch request here? We essentially have to give it the exact same information we did over here in airport. It's one of these fetch requests. So we have to give it a predicate, what this entity name is, what the sort descriptors, and you can do that. There's something, I think it's called, yeah, here it is, entity. You would say something like flight.entity. And then there's sort descriptors, you would put those. And then there's also another one, predicate, and you put those. But we're not going to do that because we really can't. The problem is, what are we trying to fetch here? We're trying to fetch things that match this flight search. So unfortunately, this flight search is passed to us. We can't use it in here to initialize this property wrapper struct. So we're going to have to do it in here. And we know exactly how to initialize property wrapper structs. We use the underbar version of it. So underbar flights, which is the underbar version of this flight, that's this struct. I'm going to set that equal to a fetch request. That's one of these structs that I'm going to create with a fetch request. So this is one of the constructors for creating a fetch request. I told you there was the other one here that took the entity and all that, but one of the choices here also is fetch request. So I'm just going to give it a fetch request. And this fetch request, I'm going to do exactly the same thing I did over here when we did the airport lookup. Let me get this. In fact, I'm going to copy and paste it. It's so similar. And here this time we're not looking up airports, we're looking up flights. So here we're not looking up the ICAO, of course, we're looking up the destination airport of this thing, which we underbarred because it doesn't make sense to have a flight without a destination. So that's why we made it so it would never be optional there. And what is the destination? It's the flight search that we're being passed. Its destination, this flight search. It's the flight search object. We changed that so its destination is an airport. So now we are doing a fetch here where we're looking for a destination equals that airport. Now we have other sort descriptor, obviously. Let's sort by, I think, arrival time. It's probably the best thing to sort our flights by. Now we have other predicate things we want to search for in here besides the destination, like the origin, airline, in the air, but we'll do that when we get our filter flights working. Okay, so for now we're just going to look for all the flights to this destination. Now you see that I've typed these 3 lines of code here. I typed the same 3 lines of code over here. They're very, very similar. You really kind of use them all the time because you're searching for objects all the time. I like to make little functions in my extensions to these that do these 3 lines of code for me. So instead of doing these 3 lines of code, I'm going to use some code that I put down here to do this. And it just makes a fetch request with a predicate, and it automatically picks the right sort descriptor. It does this little entity name thing to create the fetch request in the first place, and then just plops the predicate that you want in there. And that changes this 3 lines of code up here to a single line of code, let request equal a fetch request, where the predicate is an NS predicate, and our predicate here was ICAO underbar equals from that sign of this ICAO. So now I don't have to do the sort descriptors and all that stuff. It just makes this code simpler. And I'm going to do the same thing for flight. So here's fetch request for flight, sorts by arrival. It's got the right entity name here. I'm going to do the same thing for airline. And I pretty much will do this for all of my objects that come out of core data to have these easy one-liners to create a fetch request for them, especially when you're almost always wanting them sorted by the same thing. An airline's almost always going to want to be sorted by its name. An airport almost always going to want to be sorted by its location. Down here, a flight almost always going to want to be sorted by arrival time. Now, if you wanted to specify different sort descriptors, of course, you could get the fetch request from here and then change the sort descriptors. It's just returning a bar here, a fetch request bar. So that makes our code back here even simpler. We can actually just take this predicate right here and say let request equal a flight fetch request, where this is the predicate. Get rid of that. It makes this a one-liner here. So now this flights bar is going to always be the result of this fetch. This is the amazing thing about this property wrapper right here. It's more than just letting you specify the fetch request. It makes it so that this var always contains the result of this fetch. Even if objects are being added or removed from the database that would match this, it always is changing this. This is just constantly being updated, this fetch results, to reflect the latest version. And it's really one of the really best integrations between SwiftUI and core data is that this ability to make these fetch results bars that are just always kept up to date. So our for each down here is just always going to be updating every time new flights come in from FlightAware or whatever, it just automatically updates. Okay, so let's keep going here. What's the next error? We can just see it right here, actually. Flight list entry, flight of flight. Cannot convert fetch result of flight elements, so the element of a fetch result of flight, which will be AKA a flight, To expected argument, FA flight. Oh, of course, because FA flight list entry, this thing down here, it expects to get an FA flight because this is the old world here, the pre-core data world. So let's fix this. This flight does not want to be an FA flight. It wants to be a flight. And one huge advantage of that is that flight is an observable object. So I'm going to say outside observed object flight. So if anything changes about this flight in the database, this view is going to redraw. This is one of the huge advantages of making this object-oriented instead of having this be a string. If this is a string, there's no way to know, oh, that flight got updated. And in flight list entry, we also have these observed objects, which are getting all the airports and all the airlines. We don't really need those anymore because when we get airlines and airports nowadays, they're objects, and we can get all the info we want about them from those objects. So we don't need to have these all airlines flight code friendly name business. Instead, I can just go here and say flight.airline.friendly name. And similarly down here, we don't just all airports look up the flight by its origin, whatever. We can just say flight.origin.friendly name. So this is all much more object-oriented, and it makes the code a lot cleaner. It's a lot, friendly name, flight number is the name, a friendly name down here for from. Less of looking up things in random lists of info structs and all that stuff. We still have all these things in Flight Fetcher. Okay, poor Flight Fetcher. Let's go over to Flight Fetcher here and from the last lecture and just comment this whole thing out because we really don't need Flight Fetcher anymore. Going to be using that. We're going to use just our database. Here we go. And no more errors. We fixed everything. Changed our world to be entire object oriented and pretty straightforward to fix all the things. And in fact, some of this code much more readable and understandable. Let's see if it works. And there it is, and it does not work. Why? There's no information. But this is actually working perfectly. It's just that there's no data in our database. So we are looking at an empty database. Here's all the flights in our empty database. So we clearly need some code to load up this database with the flights to the destination airport. So let's do that. Over here, here's where we create this SFO. Let's create a little airport function here called fetch incoming flights. This is just going to go off to FlightAware, fetch all the flights that are coming to this airport right now, and put them in the database. And then everything will just work from there because the rest of our code is just looking in the database, just waiting for something to happen, right? This fetch right here is just sitting there waiting for this to start giving some results, and it's just going to redraw and automatically do it. So let's go to airport here and do this fetch incoming flights. Now the fetch incoming flights I also have commented out. It's mostly, again, this FlightAware stuff. But I do want to focus on this line right here, this context equals managed object context. You notice that when we created this function fetch incoming flights, we didn't pass the context, the database context, as an argument. So you might wonder, how are we going to create flights? We're fetching incoming flights. How are we going to create them in the database if we don't have a context? Well, this method, fetch incoming flights, is an instance method on an airport. And it turns out that all objects that come out of core data, airports, airlines, flights, any of them, they know the context they came out of. And we're just going to use that same context to put our flights in. So this line of code, if let context equals managed object context, is just accessing a var in the airport, which is what is the managed object context you came out of. And this is really important to know because otherwise you're going to end up passing context around all the time unnecessarily. When you have an instance from the database in your hand, you can always get the context from the database and add more objects or fetch other objects using that. Here's the asynchronous closure that's executed when the information comes back from FlightAware. So this is very similar to what we had up here when this airport info request fetched an airport, and here's where it came back with the result. We have the exact same thing going down here where we have the result. So what am I going to do when the information comes back from FlightAware? Well, this is an array of FA flight. You all remember FA flight over here has all the information that comes back from FlightAware. So I'm going to go through all those FA flights with a for loop, for FA flight in those results. And I'm going to call a function in flight that updates from an FA flight. Again, just like I have update from up here that updates from airport info in airport, I'm going to put this method, almost exactly the same method, but with all flight-oriented stuff here, into flight. So let's go over and do that. Here's flight. And you can see it's doing this same thing, fetch request, looking things up by ident, all these things. This, again, could be let request equal fetch request with this predicate. So we can make that a one-liner right there. And so we're searching for this flight by whatever its ident is in the FA flight. That's what the search predicate is. And we're doing the exact same thing we did in airport, looking to see if we found a result, if we find it. In this case, though, flights are a little different because they get updated over time. So if we find it or not, we're going to update it with whatever information came back. And this is all this stuff we saw before. A couple of interesting things going on in here is here I'm setting some relationship vars. So here's my origin and destination airport. Look what I'm doing. I'm creating an airport with that origin var, because an FA flight origin is a string. So I'm looking that ICAO up in our current context, the context that was passed into us here, and creating an airport. Same thing here for the destination and airport. And I have to do the same thing for airline, because in FA flight, airline code is a string. So I need to create an airline. So in airline, we need a little thing that looks it up, and if it finds it, returns it. If not, it creates it, just like we had in airport. So let's go do that in airline. And this with code looks very similar to the airport. It's just that these are all different down here. We're still doing the object will change though here, and same thing with the flights. So if this airline information comes available from FlightAware, we're going to do object will change on all those things. One other thing I wanted to show you is when I'm loading up these flights, I'm going to show you what it looks like to try and catch the error from context save. Just because we haven't really been doing this, we've been doing try question mark everywhere. But if you just put a do catch around the thing you want to try, this throws an error, and this will catch that error. And then you can do things like print out that error's localized description or something like here. And here we can handle the error where we tried to save the context and we couldn't. If your context save fails, something pretty bad going on. Maybe your disk is full, or something pretty heinous is happening here. So there's not usually much you can do to handle failure to save. Maybe try to save again in a few seconds or something, but it's a tough one to recover from. So that's all that's happening here in fetch incoming flights. So we're just loading up the database with things that are coming in from FlightAware. That's all we're doing repeatedly. See if that works. Woohoo! Look at that. Loading it up in the database, and wow, now our database is showing a lot of flights, and they're still coming in. It's loading more and more flights. And what we're looking at here, though, is the database. This is purely looking at the database. All this flight fetching that's happening asynchronously to what's going on here in the UI. Now, glancing at my code there on the left, I can actually see we forgot something, which is we don't have our flight do its object will change, even though we're possibly doing a big update to a flight there. And then also I see a problem here at the top where it's not saying flights to KSFO, it's saying flights to airport 0x whatever. And that's happening because we're printing out an airport object there instead of printing out its ICAO code. So let's fix both those problems. Starting with right here, we forgot to say that we want our flight that we just created to have its object will change.send sent, because we just changed a lot of fields and we want to make sure that our UI will update with whatever that is. And then we can fix that title problem with the airport, which we're doing over here, by saying backslash open parentheses, close parentheses with the object. We don't really want the object here. We want this destination's ICAO. So let's see that, fix that problem. Oop, there it is. There's its ICAO. All right, the last piece we have to do is fix our filter right here, because our filter, I'm not sure what it'll do right now. It's not going to work because this filter is built to work with strings. You're supposed to be picking strings over here, this filter flights, and we changed all of our flights to be objects, so this needs the object-oriented treatment as well over here. Now, when we're letting people choose airports and airlines, we actually do need all the airports and all the airlines that are available. But we're not going to do it again with these old view model airports all and airlines all. Instead, we're going to do fetch requests here. And these are going to be fetch requests for airports and airlines. So I'm going to do a fetch request, and I'm going to have the fetch request here be hardwired in here. It's going to be airport.fetch request, where the predicate is essentially I need all my airports. Okay, I'm going to use this fetch request to get a little var airports here, which is going to be all of my airports. All right, this is the same fetch results thing that I was doing over here, but over here I was doing the fetch results based on looking up the destination airport. In this case, I want all of my airports. So what kind of predicate means all? Well, there's a great predicate for that called true predicate. That just basically means this evaluates the true at all times. That's so common to use. I actually created a little extension called to NS predicate called all, which does that, and none, which does the false. It seems like I'm always doing a predicate, true predicate somewhere in my app. So I'm going to change that to all. And that's it. That's going to fetch all the airports. This airports var will always be all the airports. Even if airports are added, this automatically updates so that this fetch results thing that we're doing for eaching inside of our pickers down here will always be updated. And same thing we'll do for our airline. Now we have all our airports and all our airlines. And we're going to use that down here inside of our pickers, because our pickers are currently picking these codes, but we want them to actually pick the objects. We want them to pick airport and airline objects. So instead of being all airport codes here, this is just going to be our airports. And I'm going to sort them, sorted. Our airports, if you remember when I showed you airport over here, I made it so that it implemented this comparable protocol. So this comparable protocol is a little less than function. And if you implement comparable, then you can have collections like airports or arrays of things sort themselves by saying sorted. Now, this is object-oriented, so we don't want to need to be looking this up like this. We can just say instead here our airport's friendly name to get the airport. And this is never returns nil, so we don't need to optionally default that. That's good. So this code actually cleaned up quite nicely. And what about our origin? Similar, except for that, of course, this is no longer a string, so we don't want the optional nil for optional string. We want airport optional right there. So that's the nil for airport. And again, not all airports code. We want airports.sorted. And again, the airport is already got its own friendly name in an object-oriented kind of way. Still want the question mark any, because this airport is allowed to be nil, and it's not optional string, it's optional airport. So now this is picking optional airports, just like this is picking airport. And this is airline down here. This is probably more similar to this than it is to this other one. So let's copy and paste right here. Change this to be our airline. And I'm going to search and replace this our port with our line. Okay. We've converted these now to use objects instead of their strings. Otherwise, this code can stay the same. One last thing that I want to do is when the done button is pressed, if you've changed your destination, I want to do this fetch incoming flights. Right? If you change from looking at SFO to looking at Dallas Fort Worth, I want to fetch those incoming flights. So I only want to do it though when you actually change your destination. So I'm going to say if my giraffe's destination does not equal my flight search destination, then self.draft destination fetch incoming flights. Let's take a look, see if this works. All right, here we go. Let's try filter. Oh no, it crashed. It crashes. We hate crashes. What is going on? Let's look at our console down here. This is a very, very important error when you're working with core data to understand what this is. It says context in your environment is not connected to the persistent store coordinator. If you remember back over here in scene delegate, we created this thing context out of our persistent store, this persistent container. This is our view into the database. And we had to pass it in to our Enroute view via this environment. But we then, from our Enroute view, put up a sheet with filter flights, and sheets get their own environments. So we have to do the same thing here and pass into this environment this context. Now, the only problem here is, what is context? It says unresolved identifier. Where is context? Well, we're going to have to get our context here so that we can pass it here. We're going to get that here from our environment, a managed object context, which is a var we'll call context. So here I'm grabbing this context out of here, out of my environment, and I'm passing it along to this sheets environment. So this guy has an environment. So this is a common error to get down here. And so really make sure that you burn in your brain what this means. It just means you needed to pass into a sheet or something, anything that puts up this modal popover, whatever, pass this context in there. And the reason for that is things like fetch request depend on that context. How else are they going to know where to get these airports and airlines from? They need the context to be in their environment. Oh yes, so we got to put a self dot over there. Now we can run it. Okay, here we go. Let's try filter. Oh, that looks better. Destination San Francisco. Woo! There's all of our things. Denver. Now that didn't fetch. That's good. Okay, I haven't said done here, so it didn't go off and do a fetch there. Origin, yeah, looking good. Airline, yeah, maybe say United. Something like that. Oh, airline not working. See that airline not working? So let's go back and take a look at airline, see what we did wrong there. Probably a copy and paste error that we made down there. So that's in filter flights. So airline, let's see, oh, look at this, draft.origin for the airline. No, this is draft.airline. Try that. All right, SFO, that's good. Now airline, oh, looking much better already. United, let's go to Boston. And I'm gonna hit done, and hopefully then it will do another fetch. Whoop, there it is, Boston. And again, we're looking in the database here. And if we go back to San Francisco, you'll notice something interesting here. Pay close attention. Oh, a lot of airports in there. San Francisco, here it is. Watch when I hit done here, whoop, how quickly SFO loaded up, because it's showing me stuff that's in the database, and it's continuing to update them, but we're getting this instant response from the database, which is another great kind of side effect of moving this stuff in the database. Now, it's not quite right yet because I changed this, if you remember, to have United as my airline, but this is giving me other airlines besides United, right? Well, that's because back here in our flight Enroute, when we're looking up our flights, our predicate here is just the destination only. This is not looking at the airline and things like that. It's the destination only. So we need this predicate right here to be some predicate, say, let predicate equal, that is based on this flight search and all the things, not just the destination. So I put a little extension down here to flight search to do that. And let's even just move it all the way up to the top of the file here. And this flight search extension that I added is to add a var called predicate that just is on flight search, right? So it's just looking at all these things and building up an NS predicate object using more and more stuff in its format. You see its format is destination. Then if there's an origin, I add and origin. If there's an airline, I add and airline. And along the way, I have this args, which is an array of NS managed object. Now, what is NS managed object? This is the superclass of flight, airport, and airline. So if I want to create an array that could have flights in it, or air origin, or airports, or airlines, then I can make an array of NS managed object. And since those all inherit from there, this works. So this is the arg, so it's putting the destination in there to start, and then if there's an origin, it puts that in there. If there's an airline, it puts that in there. And then we're just saying NS predicate format, this string we built up, and the argument array is these args that I built up. So this is how you can kind of build a programmatic predicate that's based on decision making, like what's in this struct. So I'm just going to use this predicate var down here and say flight search dot predicate. Give me a predicate for this flight search, and I'm going to use that to search here. We don't need that anymore. It's simpler. In fact, this is so simple we could just put this right in here like that. See if that works. All right, notice SFO instantly showing us data in the database, the data that's valid anyway to show us. And let's go airport here and go down to United. That's a hub for San Francisco, so there should be flights, and sure enough, there it is. That's working. And we could go origin. What was in the origins there? Boston. Okay, we can find Boston. We know where Boston is there at Logan Airport in Boston. So now we're going to look both at Boston and United. Oh, found that. It's good. And we could go back to saying, show us any that are coming from Boston. Yep, still on this one flight. And go back here and say, show us any airlines, any place. Here they are. All right. So that's a lot of code in that demo, a lot to show you there. But hopefully you've gotten a good feel for how we build our UI out of data it's in the database, especially the way we do these fetch requests that are having results that are just constantly kept up to date as we change things. And that makes it so the rest of your code doesn't have to have as many if-thens and things change and this, that, and the other thing. It just finds them. And notice that in core data, we're mostly using these fetch results to have things change, even though we can also use observed objects on individual flights, airlines, arrays. And we're using it here. If this flight did change, since we did the object will change.send on there, it would update. But that's more rare even than doing these fetch results. Really fetch results and having this dynamically always show you what's in the database. That's really the heart of the SwiftUI to core data integration. All right, I'd really love to see some of you do this in your final project. There's certainly a lot of need in a lot of different project ideas for permanent storage, persistent storage, and this is a lot more powerful than doing user defaults. So I'm hoping that you guys will tackle this.
For more, please visit us at stanford.edu.